What exactly happened during liftoff of Artemis 2 SLS rocket? Is everything okay, or is there a problem?
Hey, I'm Lucas. Welcome to the SpaceX community. Let's get started.
A little over half a century since humanity last ventured beyond low Earth orbit, today's launch of Artemis 2 marks a moment that feels both historic and transitional. Not just because of what happened on the pad, but because of what it represents for the next decade of exploration. At 6:35 p.m. Eastern on April 1st, NASA's Space Launch System roared to life from Launch Complex 39B, carrying 4 astronauts aboard the Orion spacecraft on a mission that, in many ways, bridges the legacy of Apollo with the ambitions of a sustained lunar presence. This wasn't just another launch. It was a statement that deep space human exploration is no longer something confined to history books. Instead, it's happening again, right now, with new hardware, new systems, and a completely different long-term vision. From a technical standpoint, the ascent itself appeared clean and nominal, which is exactly what NASA needed given how much scrutiny the SLS and Orion systems have faced over the past few years. Roughly 8 minutes after liftoff, the core stage completed its job and separated, leaving the Interim Cryogenic Propulsion Stage, or ICPS, to continue pushing Orion into its initial orbit. This phase is often overlooked compared to the dramatic visuals of liftoff, but it's one of the most critical segments of the mission. Any deviation here can cascade into major trajectory issues later on, especially for a mission that ultimately needs to send humans around the moon and bring them safely back. Interestingly, the lead up to launch wasn't entirely without concern. During the countdown, teams identified an issue with the flight termination system, along with a separate anomaly involving a battery in the launch abort system. On top of that, there was also a brief loss of telemetry from the vehicle. Individually, none of these are unheard of in complex launch operations, but taken together, they highlight just how tight the margins are on a mission like this. The key takeaway, though, is that all issues were resolved before the window opened and, more importantly, without forcing a scrub. That alone suggests a level of maturity in both ground operations and vehicle readiness that NASA has been working towards since Artemis 1. Inside Orion, the crew, Reed Wiseman, Victor Glover, Christina Koch, and Jeremy Hansen, are not just passengers but active participants in testing the spacecraft's capabilities. This is something that differentiates Artemis 2 from Apollo-era missions. Back then, many systems were proven incrementally, but today's Orion is expected to perform at a much higher level of autonomy and reliability right from the start. The crew's role includes manual maneuvering, system validation, and operational feedback that will directly shape future missions. In other words, this flight isn't just about going around the moon, it's about learning how to operate in deep space again. After reaching a low transfer orbit, the ICPS is scheduled to perform a series of burns that gradually reshape Orion's trajectory. The first burn, occurring about 49 minutes after liftoff, raises the perigee to ensure orbital stability. Then a second burn pushes the apogee out beyond 70,000 kilometers. This creates a highly elliptical orbit, which Orion will occupy for about a day before separating from the ICPS. That separation event is another critical milestone, as it marks the point where Orion truly becomes an independent spacecraft, no longer relying on its launch vehicle. What happens next is arguably one of the most fascinating parts of the mission. The crew will manually maneuver Orion around the ICPS, effectively performing a proximity operations test in deep space. This may sound routine, but it's anything but. These maneuvers are essential for future missions where Orion will need to rendezvous and dock with other spacecraft, including lunar landers. By practicing these operations now, NASA is building confidence in both the spacecraft and the crew's ability to handle complex scenarios far from Earth. Once these tests are complete, Orion's main engine will fire, sending the spacecraft onto a free return trajectory around the moon. This trajectory is carefully designed so that even in the event of a major failure, the spacecraft will naturally loop around the moon and return to Earth without requiring additional propulsion. It's a concept that dates back to Apollo, but its inclusion here underscores just how much emphasis NASA is placing on crew safety for this mission. If everything proceeds as planned, Orion will splash down off the coast of San Diego on April 10th, bringing the mission to a close. But in many ways, that splashdown will only mark the beginning of a new phase in human spaceflight. The Artemis 2 crew will become the first humans to travel beyond Earth orbit since Apollo 17, a milestone that carries both symbolic and practical significance. It signals that the infrastructure for deep space exploration is not only back but evolving. Of course, getting to this point hasn't been straightforward. Artemis 2 was originally scheduled to launch in late 2024, serving as a precursor to a lunar landing on Artemis 3 just a year later. However, delays, particularly those related to the Orion heat shield, pushed the mission back by more than a year. The heat shield issue, which stemmed from unexpected erosion observed during Artemis 1, required extensive analysis and redesign. While delays are never ideal, this is exactly the kind of problem you want to uncover during an uncrewed test flight rather than during a mission with astronauts on board. These delays have also had a ripple effect on the broader Artemis timeline. Under revised plans announced earlier this year, Artemis 3 will no longer attempt a lunar landing. Instead, it will focus on demonstrating Orion's ability to rendezvous and dock with lunar landers in Earth orbit. This shift reflects a more methodical approach to building out the capabilities needed for sustained lunar operations. Rather than rushing to a landing, NASA is prioritizing the development and validation of key technologies. Looking further ahead, Artemis 4 is now slated to be the first mission to land humans on the moon since Apollo, with a target of early 2028. Artemis 5 is expected to follow later that same year, marking the beginning of a more regular cadence of lunar missions. These missions will rely heavily on partnerships with commercial providers, including Blue Origin and SpaceX, both of which are developing lunar landers. NASA's decision on which lander to use will depend on the progress each company makes, adding an element of competition that could accelerate innovation. In many ways, today's launch represents a turning point. For decades, human spaceflight has been largely confined to low Earth orbit, with the International Space Station serving as the primary destination. Artemis 2 changes that narrative. It demonstrates that we have the capability and the commitment to venture further. At the same time, it highlights the complexity of doing so in a sustainable way. Unlike Apollo, which was driven by geopolitical competition and short-term goals, Artemis is about building a long-term presence beyond Earth. As Orion continues its journey over the coming days, the focus will shift from launch operations to in-flight performance. Every maneuver, every system check, and every piece of data collected will play a role in shaping the future of Artemis. This mission is as much about validation as it is about exploration. It's about proving that the systems we've built can support not just one mission, but an entire campaign of human exploration beyond Earth orbit. And that's really what makes today's launch so significant. It's not just a return, it's a reset in how we approach deep space exploration, how we design spacecraft, and how we plan missions that extend far beyond a single flight. Artemis 2 is the first real step in that direction, and if today's launch is any indication, it's a step that's been a long time coming, but one that's finally here.
Thanks for watching today's episode. Don't forget to subscribe and give us a thumbs up if you enjoyed it. Stay tuned for another great video tomorrow.